The next way we'll look at convergence of series is going to be the ratio test. For the ratio test, we're going to start with our sum of a sub k, and we're going to let r be the limit as k goes to infinity of the absolute value of ak plus 1 over ak. So we have this ratio going on. This will converge if this value r is greater than or equal to 0 or less than 1. It diverges if my ratio r is bigger than 1, and it's inconclusive if my ratio r is equal to 1. So let's do some examples and see if we can figure out how to do this. For my first example, I have the sum from 1 to infinity of 3k over e to the k. So I need this value r, which is the limit as k goes to infinity of the absolute value. We're going to add 1 to all the k's, so 3k plus 1 over e to the k plus 1, all over the original series, 3k over e to the k. And now we need to simplify this. So I have the limit as k goes to infinity of, well, first off, everything's positive here, so I'm going to ignore the absolute values. I have 3k plus 1 over e to the k plus 1. And when we divide, we flip fractions. So times e to the k over 3 to the k. We can then simplify, and whenever we divide, we subtract exponents. So k plus 1 minus k is 1. So I'm left with a 3 on the top and an e on the bottom. And now I just need to know if this number is bigger than or less than 1. And well, 3 over e is 1.104 roughly, which is bigger than 1. So this series will diverge. Next, we have 1 to infinity of k factorial over 3 to the k. And first, as a reminder or maybe new information, what this factorial thing means. So it means, for instance, 6 factorial. It multiplies that number by all the numbers less than it. So 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. So it multiplies an integer by all of the positive integers less than that. If I want to do my ratio test, I have the limit as k goes to infinity of the absolute value of k plus 1 factorial over 3 to the k plus 1, all over k factorial over 3 to the k. Once again, all of this stuff is positive, so I'm going to drop the absolute values. So I have k plus 1 factorial over 3 to the k plus 1 times 3 to the k over k factorial. So now we need to consider how to reduce this. Well, first off, properties of exponents say that we subtract, so I'm left with a 3 on the bottom. And now I just need to figure out my factorials. Well, k plus 1 factorial means I'm going to multiply k plus 1 by k minus 1 all the way down to times 2 times 1. And k factorial means I multiply k by k minus 1 all the way down to 2 times 1. And if I were to divide these, we can see that all of this stuff cancels, and I'm just left with a k plus 1 on the top. The limit as k goes to infinity is now infinity, so this series diverges. Now let's consider the sum from 1 to infinity of 1 over k squared. I'm going to take the limit as k goes to infinity of the absolute value of 1 over k plus 1 squared all over 1 over k squared. Once again, I'm going to drop the absolute values because I'm only dealing with positive numbers. I then have 1 over, and I'm going to go ahead and multiply this out to get k squared plus 2k plus 1. And then we flip fractions when we multiply. So this is the limit as k goes to infinity of k squared over k squared plus 2k plus 1. And when I take the limit, since I have a k squared on the top and the bottom, my limit's just going to be 1. So my test here is inconclusive. I would need to use a different test to figure this out. And we actually can. We've talked about the p-series test, and in this case p would just be my exponent 2. Since that's bigger than 1, we know that this series does actually converge.